Now let's do the same thing for the z2. For the z2, its modulus R2 is equal to the square root of the square of 4 times root of 3 plus square of -4. And this, okay, you can factor out this 4 square. The inside you have the square of root of 3 and plus -1 square, same as the 1 square. So now you have the square root of the 4 square, and then square of the root of 3 plus 1, so it's 4. So you have another 4. Then you have the 4 square times 2 square. So you have the 4 times 2, you got 8, right? So now let's get the argument of this complex number. Cosine theta 2 is equal to the real part of this complex number, 4 times root of 3 over the modulus. So it's the root of 3 over 2. So now we can get the arc cosine of the root of 3 over 2, and this is equal to pi over 6. But this pi over 6 is not argument of this complex number. Actually, you also need to draw the sketch of this complex number. So this is 4 times root of 3 minus the 4 times I. So it's about here. And this is the negative pi over 6. So actually the argument, this guy, right? So theta 2 is equal to this 2 pi plus this negative pi over 6. Okay, and then this is equal to 11 pi over 6. Okay. Now we can rewrite this z2 in this trigonometric form. So that is 8 times cosine of the 11 pi over 6 and plus I times sine of the 11 pi over 6. Now we can multiply these two complex numbers and also divide them. So let's first get the product. So z1 times z2, and this is equal to 2 times 8, the product of their moduli, and then times cosine of the 5 pi over 6 plus I times sine of the 5 pi over 6, and then times cosine of the 11 pi over 6 plus I times sine of the 11 pi over 6. Then you just add these two arguments, right? So you have the 2 times 8, 16. Then you have the cosine 5 pi plus 11 pi, you have the 16 pi, right? So you have the 16 pi over 6 and plus I times sine of the 16 pi over 6. Then simplify, you cancel the common factor 2 from the numerator and denominator, you have the 8 pi over 3. And if you divide the 8 by 3, then you get 2 as the quotient and also 2 as the remainder, right? So now you can rewrite this 8 pi over 3 as the 2 pi plus 2 pi over 3. Then you have the 16 times cosine of the 2 pi plus 2 pi over 3 and plus I times sine of the 2 pi plus 2 pi over 3. Since 2 pi is the period of the sine and the cosine, so we can throw away this 2 pi. Then we get cosine of the 2 pi over 3 plus I times sine of the 2 pi over 3. What is the cosine of 2 pi over 3? What is this guy? So to get the cosine of the 2 pi over 3, we first need to find the reference angle. The reference angle of the 2 pi over 3 is the pi over 3, right? And 2 pi over 3 is in the quadrant 2. So this should be equal to negative cosine of the pi over 3. Okay, so this is equal to negative 1/2. And then similarly, sine of the 2 pi over 3, which is not the sine of the 3 pi over 2. Okay, I confused the 2 pi over 3 with the 3 pi over 2. So this guy, also we get the reference angle pi over 3, and the sine of the 2 pi over 3 is positive, so this is just equal to sine of the pi over 3. And then you have the root of 3 over 2. Okay, let me correct this. So now this should be equal to 16 times negative 1/2 and plus I times root of 3 over 2. Now you multiply each term by this 16. You have the negative 8 and plus 8 times root of 3 and then times I. And then we finish the product of these two complex numbers. Now let's get the quotient. So we have the 2 over 8 and times cosine of the difference of their arguments. So you have the 5 pi over 6 minus the 11 pi over 6. So there is a 5 pi minus 11 pi over 6 and plus I times sine of the 5 pi minus 11 pi over 6. You have the 1 over 4 times cosine. So 5 pi minus 11 pi, you have the negative 6 pi. Negative 6 pi over 6, you have the negative pi. Same here, you have the sine of the negative pi. And what is the cosine of the negative pi? First, you know cosine is even function, right? So this guy is equal to cosine of pi. What is cosine of pi? Negative 1. Right? Negative 1. And the sine of the negative pi is equal to 0. Okay, so we have the negative 1 times 1 over 4. This is I plus 0, I times 0. So finally, you have the negative 1 over 4. And then we find the quotient. So it's kind of long, for this problem, because first we need to convert this A plus BI form to the trigonometric form, and then use the trigonometric form to multiply these two complex numbers and also divide these two complex numbers.